can already hear the music.
That's a good point. I forgot to share my sound. Thank you for letting me know. All right, you ready? Here we go.
Ready. Let's do this.
Minus X minus 10.
Can already hear the music.
8, 7,
That's a good point. I forgot to share my
6,
sound. Thank you.
5, 4, 3,
All right, you ready?
2, 1, 0.
All righty, here we go, everybody. Welcome to our second. John already put his hat on.
It doesn't have the moon at noon pin yet, so he's not.
That's why I'm wearing it, because I'm showing that it's bare. You can see the hat that I am wearing, and you can see that it is bare. It is. We're waiting on my pin.
We'll get it to you. We'll get it to you in due time. We did, John, in between last session and this session, John got his official "you did it, but old school stylies" email from Dave. So congratulations to John, who has now achieved his Explore the Moon certificate with a small telescope.
Next is the Messier certificate, which the pin for that has a picture of Saturn on it. So
wait, what?
Yeah.
Oh, guess I shouldn't say act so confused publicly. Yes, of course it does. Anyway, welcome everybody to our second episode of Explore the Moon at noon in Eastern time, as pointed out by Troy already. Sorry, everybody who's not in Eastern time. Today, we are going to actually dive into the targets that we're looking for on the moon. Before we do that, we have just like a bunch of resources to share. And the first thing that we wanted to cover was how we talked a little bit about the moon phases, like the actual phases. We looked at that calendar last time, but now we want to talk about how they actually work. And we have a demo to do, which means I'm going to turn off the light that's lighting my face at the moment and turn my background off. This is something you can do at home. And I'm going to do my best to demonstrate it here. What you need is a light bulb of some kind. It helps to have a bare light bulb, so like literally just a lamp without a shade on it. I only have my headlamp. So we're going to make do with what we have. You, right now, you right there, are the Earth, and this is the moon. And our light is going to be the sun. When you do this at home, the sun will be fixed. And you, as the Earth, will move around, and you'll be able to rotate and change the position of the moon around you, as John is currently doing.
Yeah, it helps to have a swivel chair.
It does, yes. Yeah. It's your axis. But unfortunately, you're a computer, and so you're fixed. So for now, we're going to move the sun around to show you how this all works. We're going to start with the new moon phase, which is when the moon is directly between you and the sun. Yes, actually, Phil, you're right. Today we are demonstrating a geocentric system, which is not what you would expect it to be. So we have you as the Earth. This is the sun, and this is the moon. When it's a new moon, the sun is directly in front of the moon, or sorry, the moon is directly between us and the sun, so you can't see it. On lunar eclipses, or solar eclipses, as is happening on June 10th, you would see the moon pass in front of the sun, but usually the axes are off a little bit, so you just don't see the moon at all, and the sun's too bright, there's no phase at all. As the moon comes around, I'm gonna have to turn the sun so that you can properly see this.
That's perfect.
Yeah, you can see that crescent phase. And then as it comes around further, you'll start to see the quarter. And then finally, as the sun is behind you, the Earth, you'll see a full moon. Hi, how pleasant. So in this case, the sun is fully illuminating the moon. In some cases, when the axes line up, the Earth will block the light from the sun, and that's when you'll get a lunar eclipse, which is happening 2 weeks before the solar eclipse on May 26th. And then as it continues along, oh my God, I can't see anything. So you'll have to tell me if this is working. Parts of the moon will start to go dark as the phases wane, and eventually back to a new moon where you can't see anything. This works best when done by yourself on your own. So we're doing our best with you as a fixed computer here. I still can't see anything because I stared right into that light.
And the most fun way to do it with kids is give them all a popsicle and go out at sunset and just have them turn in circles.
True, because the sun at sunset is
it's like a fixed point. Then you
like
and then you can go through the phases like that, and then you take pictures of everyone acting like a goof.
That's
you remember those pictures forever.
You save them for blackmail later. So that's Linda has said as well. I was using a styrofoam ball for this, as you can see. I really like it because this isn't a perfect styrofoam ball. This is one of those ones that has like little bits.
Like a floral sign of styrofoam ball.
Yeah, because then that emulates the craters that you see along the Terminator. Definitely a good option. Give it a try. If you have a golf balls work too, because they also have dimples on them, which represent the craters. So give that a try. Just spin around in a circle, spin counterclockwise, because that's how the moon orbits us. And when you, as the Earth, and you have the light bulb staying still, when you as the Earth turn, you're simulating the month passing. So you're not simulating the turn of the Earth every day. For that, you'd have to keep the moon in one spot and you would turn and the moon would shift a tiny, tiny bit. You're simulating just the moon going through its month-long phase. Give it a try. It's a good time. Okay, enough of that. Next, we wanted to touch on, let's see, cardinal directions, northeast, south, and west, which I'm going to throw over to John because I find this extremely confusing.
So I just had to look it up in my book, 50 Things to See on the Moon. So when
hashtag not sponsored,
but actually
shameless plug, no shame at all. Yeah, so when a lot of the time when we talk about things on the moon, you might be like, oh, Endymion, which we'll talk about today, that's to the north, or the Gang of Four, that's to the southeast. So and it gets complicated if your telescope is mirror reversing or something, so you have to keep that in mind. But when we talk about the moon, not necessarily if you're looking at it in a mirror reverse scope, but just when we talk about it, if something's at the top of the moon, as if you're just looking at it, for us in the northern hemisphere, that's the northern part of the moon, right here. And the bottom of the moon, like where Tycho, that big ray crater, and Clavius, that's the south end. And the left side of the moon is the west side. So we'd be like, oh, that's to the west. So the Terminator is moving to the west. And then the east side of the moon is, the right side. Yeah. And
so it's like you're looking at a map.
It's like you're looking at a map. Yeah, it's not a whole lot different. And if you're looking through the scope, this is something I just learned today, but it's going to be a little bit backwards for the moon. But if you're looking at the stars through your telescope, the stars will always drift to the west, the cardinal west for you.
And
but if you're looking at the moon, the eastern side will disappear through your eyepiece first. Yeah. But it is drifting. Traveling. If your telescope is not tracking, the moon is drifting westward. Anyway, I just thought that was, I never really thought about that before. So that was the new thing I learned for the week.
Is it the same thing in the southern hemisphere? I don't know if we have any.
Well, if you're looking up, the south side will be up. That's the top of the moon. Yeah.
It's all backwards and strange in the southern hemisphere, and I can barely grasp it in the northern hemisphere, so I'm too afraid to approach it for the southern hemisphere.
I recently learned they don't have I should know this, but they don't have a star to match up with the southern hemisphere.
Yeah.
Your telescopes.
Yeah,
it's a tough time down there, I assume. Earth tried to observe the southern hemisphere. I just wanted to also mention, because this was mentioned by Zoe in the chat, that if you're looking for Wilma, which, why am I doing this on a piece of paper? I'll just show you on my computer screen. If you're looking for Wilma on the moon, which is a shape that the Maria make, Wilma looks west. And then actually at this point, Samantha, how would you feel about sharing your Maria photo?
I have that set up, so I can share. Is this the right? Sorry, I'm just gonna make sure I have the right thing up. Okay.
We're gonna have to start bringing Tilly hats to our class apparently to fit in with Dad over here.
Yeah.
It's funny because it's like slightly too tight, and so I get this red line here.
That's a look.
There we go. I found the right. I have too many windows open. So we have these maps. The full moon, since you can't really see any craters because there's not the Terminator there, we have developed the C map, or the Maria map. So this is the binocular view one. And here are all the Marias. So Marias are best viewed on like a full moon day because you can see them all, and they're so big. Sometimes they just get cut off by the terminator, as you'll see when you go through the Q-Day files. We have still labeled them because the binocular program does list them with the Q-Days. But when you have a full moon and you go out to sea, we suggest trying to get as much of the Maria or the bays, all that as you can, but you can go back and catch them as well the second time. But I believe you wanted to talk about something on here, Jenna.
I did, yeah. I'm gonna bring up, because it's actually somewhat more difficult to see than I was expecting. So I'm gonna bring up another photo as well. A couple people use the man on the moon, the rabbit in the moon, various different seeing techniques to try to figure out where the Maria are and like orient themselves. Ever since Chris Vaughn showed us the Wilma in the moon, that's all I can see now. And so I'm going to share my entire screen and just show this photo of the full moon here, which is going to be on the 26th of April. Wilma is here. There's her hair. There's her eye. There's her smile. So this is Wilma's face.
Where's her nose?
I honestly, it's
Kind of looks zombie-like,
like
you know?
maybe she doesn't have one. She's had some interesting surgeries now. So this is, I made this like this dark spot.
Okay. Because when you first mentioned Wilma on the moon, I pictured the Erebrium as her nose, like the that the bay there. So
Here?
I got it totally backwards.
Here?
Oh gosh, why am I blanking on it? That's C in the little bay near Plato.
Like here?
Sinus Iridium.
Okay.
Sinus Iridum was the nose for me.
Oh, isn't that up here?
Yeah, so that's my nose for Wilma.
Okay, so
I'm
not
all
John's
messed up.
Wilma. Don't be John.
Don't be like me.
Don't be like John. This Wilma here with her, this is her hair, like in her little curly hair bun things, and then her face looking this way. She's looking west. So this is west on the moon. That's east over here where Mare Crisium is. And then we have north and south. Okay.
Moving on.
Onto the next thing that we were going to talk about. I know you can all see my cheat sheet here. That's fine. John's going to talk about telescope moon viewing tricks. Over to you, John.
Yeah. So when I did Explore the Moon, I started off using 3 separate beginner telescopes because I really wanted to experience what a lot of folks go through, because people that buy sort of the department store, maybe telescopes that aren't really up to snuff, a lot of them, they lose their love for astronomy apparently early on because they can't get their telescope working, and the telescope goes in the closet forever. So a lot of what I do is trying to get people to get that telescope out of the closet and have small wins. So that I could relate, I started using these small telescopes. So if that's you, I want to help you sort of get the best out of the experience. And I settled on using probably the worst telescope to buy if you're a beginner, and that's like the Celestron 70 EQ. So it's a refractor like this, except it's equatorially mounted. So you point it at the North Pole and then you twist a little slow motion control to track with the Earth. So again, that's a Celestron Power Seeker EQ, not recommended. It's just got too many issues, but to buy. But if you already have one, and this is sort of similar in terms of setup, some of the things that helped me are as follows. For one, most of these beginner telescopes have what's called an erecting eyepiece right here. So, or an erecting diagonal. So usually beginner telescopes, or a lot of probably even the more advanced ones, come with a diagonal that's just a mirror. Okay, and then that's how you get that mirror image of the moon. And I found that a little bit more complicated, because most of the maps when we talk about the moon are binocular view. So, everything's normal, quote unquote. But by using the beginner telescopes, it actually made it a little bit easier, because that gives these refractors the binocular view when you use one of these. The other thing that helped was starting off at low power, just to get used to finding the moon, right? So if I just put my largest focal length eyepiece. So if you look at the number on your eyepiece, like this is 26, like that's a fairly large focal length eyepiece. If it was 10 or 6 or something, that would be small focal length, and that would be a lot of magnification. So the magnification is, you can calculate it by taking the focal length of your telescope, which is usually written on a sticker on the side, and dividing it by the focal length of the eyepiece. So the higher the focal length on the eyepiece, the less magnification. And when you start off, that's what you want. Least magnification possible. The issue I had with that is that I couldn't see the crater. So you'd have the moon wouldn't fill the field of view. So if my field of view was the zoom screen, the moon would be like this at the least amount of magnification. And it wasn't quite enough to see what I needed to see to complete the program. So basically what I did, almost all beginner telescopes come with a Barlow. So this is a 2x Barlow. They go in between the diagonal and the eyepiece. And this gave me about 50 times magnification, up from about 25. And this was perfect. Now the moon filled the field of view. It wasn't zoomed in on the craters like you might have with a larger telescope, but it was really perfect for seeing everything I needed to see. And so that's that. And the other thing that I didn't use but would really have helped, especially for some craters like Cook or any crater that you're viewing past the recommended Q day, is a polarizing filter. So again, this is something a lot of beginner telescopes come with these. It basically just says moon on it, or polarizing. But what this does is it increases the contrast of what you're seeing. And what polarization does in general is it dims down reflected light. And because all the moonlight that we get is reflected, it's highly polarized. And these filters really help with the contrast.
I think Jenna gave us a hot tip last time. If you don't have that, you wear polarized sunglasses.
Yeah, so that's another thing to talk about though too, is so I have a pretty strong prescription in my glasses, but I never stargaze with glasses. You can focus the telescope to your prescription. So I'll take them off. The challenge with the Explore the Moon program is you need to sketch. So you're either trying to sketch without glasses, hence some of my poor handwriting, sorry Dave, or you're going back and forth, glasses, no glasses, glasses, no glasses. But also eyepieces though, they usually have this eye cup. If you are wearing glasses, you flip it down or take it off altogether. And then you just press your glasses right up. So that helps. I mean, the other thing to keep in mind, make sure that you go out during the day, point your telescope at a chimney, make sure the telescope and the finder scope are pointed at exactly the same spot, because as the moon drifts across the sky, and pretty much if you're sketching, every time you go back to the telescope, 30 seconds will pass, you're going to have to, over constantly. And so you're going to lose the moon if you're sketching a little too long. So you're going to want that finder scope really dialed in so that you can find the moon quickly again. Any questions?
Go and practice. Yeah, if you have questions about telescopes, now is the time. We do have a bunch of videos on our YouTube channel, on RASC's YouTube channel, if you're interested, if you're starting with a new telescope and looking for help setting it up and stuff like that. So you can head over and check those out. I also want to take a quick second and promote the fact that I stole these 2 books from the office. So these are now available for purchase. I'm going to switch the background off again. These are logbooks for each of the programs. They're online. They're on the website, rasc.ca/moonatnoon. You can do either the binocular one or the telescope one. The entire program document is in there with the list of all the objects, the pictures of the moon, and places to sketch them. It's a useful thing to have around so that everything's all in one spot. And I recommend you give them a look. They're really great for the program. One last tool I wanted to mention as well was we just finished double checking the calendar, not these things. So the calendar is now up on the website with the Q days for each day throughout the program. You can see which days are going to be our observing nights, which days are just Q days. I made this before Dave Chapman pointed out that perhaps I should not use just Q. I should write Q day. So I apologize. It's different from what's on the website. Q4 is Q4, Q-3 is Q-3. Here's where it gets tricky though, because the moon is, we're only seeing it for a very short period of time each night, especially early and late moons. So like Q -5 and -6 and Q day 5 and Q day 6. We're only seeing it for like an hour each night on those nights. And everyone's hour is different a little bit. So there are nights, for example, this week coming up, where some objects are visible on some nights from Q day -5, which is today's day, and some objects are not. So here's the moon on the 14th, which is our technical observing day for this week, is Wednesday, April 14th. And I'm gonna let Samantha take over. This is a more detailed photo of, so if you click on this photo here, and it'll download this for you. So this is Q day 14. You can see in detail a lot of really nice stuff. You can see these 4 craters here, which we'll get to in a second, but it's missing one of Q day negative targets. You cannot see it. To see that one, you have to go out the next day.
So when I made the maps, a couple of things. Because I'm in Waterloo, I set it to my time zone and everything. So these maps are made for kind of central Ontario. So if you're in BC or out east or down east, I always get that mixed up, then you might see it slightly different because we can't like perfectly predict where the terminator is going to be all the time. So as you can see, the Edimon, I think that's how you say it, is kind of covered. So I kept that in there just so you know where it was, but this Q day coming up in April, -5, will not be the ideal day to view that. So you can actually go back, and I'm not sure if Jenna wants to show, if you're can I share my screen?
Yeah, go for it.
Okay. If you are a morning person, you can go back the next day. You can go back when it comes around for the 3rd quarter. So it's -5 with the waning. And you'll be able to see it. There, as you can see, it's full now, and you can see all the gang of 4, like Cenis and Stevenus, which we'll go into, were covered before. Alternatively, you might be able to view it the next day as the terminator slightly shifts, but sometimes they'll be too far out of the shadows. So it's really just, you need to kind of get what you can on the days, but know that there will be a viewing day for you. And as I said, if you're in Nova Scotia, you might be able to see all of them, while someone in BC might not be able to see as much as you can. So yeah, we've made these maps. They are made for April specifically, but they're not good. Each month will not show the exact same like thing on Q day. It's a rough sketch. So keep that, just keep that in mind when you're using these maps. They're not perfect, but Jenna does have a tool that you can see exactly what you're going to be able to see. She'll share it.
Yeah. So so that's where I got these photos from, and that's this website. Again, it's on rasc.ca/moonatnoon. So is the calendar. So if you want, I'll just show you where that is. So there's the link. This is rasc.ca/moonatnoon, our main page for this program, and where we're putting all of our resources, along with what type of moon it is, whether or not it's getting bigger or smaller, waxing being getting bigger, waning being getting smaller, and what day to observe these targets is next possible after this session. So like this will be the next Q day -5, but there are other Q day -5s in forever. As every lunar cycle, there's 2. There's one in the waxing phase and one in the waning phase. So this gives you an idea of when to observe and what exactly is going on. There's the calendar, and this website that I'm about to show you is called NASA Dial a Moon. And it tells you exactly what the moon's going to look like with its tilt and everything at any given time on any given day for this year. The thing I want to note is that it's in Universal Time, which is a weird time zone. So for example, Universal right now, Universal Time, it's 4:24 p.m. So in Ontario, that means it's 4 hours ahead. And Ontario and Quebec, it means it's 4 hours ahead. So when you're looking at this, and we're saying we want to observe April 14th in the evening, the evenings, let's say 7 o'clock. So we'll do 8, 9, 10, 11 in UT. So that's 2,300 hours, and that'll give us the moon for that evening. If you're observing in the morning instead, in Ontario, let's say we want to observe at 6 a.m., 7, 8, 9, 10 UT, and that's what the moon would look like in the morning instead. Of course, you can't see it in the morning in this phase, but if you could, that's what you would see. So this gives you exactly what you're going to be looking for. It doesn't tell you whether or not you'll be able to see it. It just tells you exactly what it is. And then when you download it, you can see even more in terms of detail. And on that note, let's dive into just one of these little changes. These two craters down here, which are on the list of targets for today.
But you can't see them, as I said.
On the 14th.
I will also note the maps I made are more for locational. You can, off this moon dial-a-moon, you can actually see the details, which John's going to tell some pretty cool things about these craters.
Yeah. So each of these maps, as Samantha has made and are available on this page, show which targets are available on that specific Q day, as do the lists in each of these books and on the website as well. They tell you exactly what you need to see and which day you can see it on. So we're going to go through them, perhaps not in as much detail as we have in the Explore the Universe targets, but we'll show you exactly where they are and what they look like. Let's start at the south end and go north. What do you think, John? Does that sound good?
Yeah, we can do that.
Cool.
The fun stuff's in the south end. Do you want to save the best for last?
Oh, fine. Okay, fair. Yeah, we'll start at the top. So I'm going to keep both open, bearing in mind that this one that's on the screen right now is the 15th, and this one is the 14th. So we'll kind of bounce back and forth between those two.
Yeah. So we're talking about what to observe on the 15th of this month.
14th or 15th.
14th or 15th. Yeah. So at the top, you're going to start with the crater Endymion, which is a great book by Dan Simmons about science. It's science fiction where the Earth gets stolen. Highly recommend that book. That's book Endymion is book 3 in the series. And a good way to remember that, if you have a really strong telescope and you look at Endymion, there's Endymion triplet. So there's 3 craters in a perfect row inside Endymion. If you zoom in at the northwest corner of Endymion right there. So that's called the Endymion triplet for those with giant telescopes. So there's my trivia about Endymion.
That's cool. And I will also mention that Endymion is a telescope target only. So if you're doing the program with binoculars, it's not a target on the list. It is a target for the telescope one.
Mm-hmm. And then next is just going from memory, Cleomenes.
Yeah, which you can't see. Okay.
So you're going to go to the other day, right? I can see it there. So I believe, again, just going from memory, I think he was an astronomer from 400 BC, and going way back here in my mind, I'm thinking he was the baddest, like the original bad astronomer. So for some reason, his handwriting was really bad and stuff. And so there's a lot of factual errors in his work. And so that's sort of what he's known for, off the top of my head.
Hilarious.
Yeah. Cleomenes.
And that's the one with all these little extra craters in it, eh?
Yeah. That one's really pronounced just to the north of Mare Crisium. So,
So zooming out, if you're seeing it from further away, it's the biggest crater north of Mare Crisium.
Yeah. And so Mare Crisium, I like to call this if you go to the day 15 there.
Oh, yes.
I call Mare Crisium the smiley, or the I think of it as like a smiley face without the smile. So you have these 2 fairly dark craters in Mare Crisium, and they're craters Pierce and Picard. Yeah. And I think Captain Picard from Star Trek was influenced by the fact that by this original Picard.
No way.
I think.
The smile, there's a little line. It looks like a little blob face. Yeah.
And it's a stretch. So I think of it as an emoji.
Yes.
So the other cool thing about this, and we're not going to show pictures of it. I happen to think that Luna 23 and Luna 24 were the last 2 Russian landers that sort of ended the Russian lunar program. So they were sample return missions. So they landed within Mare Crisium. Those are not targets for this Explore the Moon program, but
no matter how much John was trying to convince us they were.
Yes, he spent a while on that.
They're there. Yeah. So that's sort of the Russian lunar program ended here with these 2 sample return missions. Only one of them worked, I believe. I don't think Luna 23 functioned. It landed and fell over or something. Anyway.
And just a heads up for Mare Crisium, it's the most identifiable. So it is one of the targets. The 2 craters inside are not, but the sea is. And it is the easterly most mare And it is also like completely separate from any other Mare. It's just like a little circle, which is really nice. Makes it easy to find.
Probably the only thing I can identify on the moon when I first started right away. So
And then
All right,
we have
now
what's
we're
our
on
next
to
one?
so the Gang of Four. Now I'm blanking on who coined that. Dave can tell you lots of stories about the Gang of Four and the Florida star parties and whatnot. So it's these I say lunar day 2, but it's Q day -5 that you have it on, right? So these 4 craters down the southeast limb of the moon show up, and they're very, very pronounced. So that's why they're on the binocular target list. I definitely have trouble pronouncing them all. My favorite is Petavius, because if you've got a big telescope and you zoom in, I call it's got the clock hands. So you'll see these ridges that come out in shadow, and you've sort of got a minute hand there at, what's that, 7 o'clock? And then at 9 o'clock, you've got sort of the hour hand.
Right there.
Yeah, so it's like
9:40
9:40 or
then.
something. It's permanently at 9:40 on the moon. Unless you're in
right,
the
2
southern
times a
hemisphere.
day.
Yeah, exactly. It's right 2 times a day. Yeah, and so those 4 craters are the Gang of Four.
So those
great
4
binocular
craters.
target. Yeah,
And then we
Languidus.
have 2 more.
I'll try my pronunciation. Oh, now they're gone.
The
Yeah.
Gang of
sorry,
Four,
we're back.
everything we've said,
Everything
Gang
we've
of Four
said
is
except for-
binocular.
yeah, these are all binocular. So Gang of 4, and then we have 2 more that are just telescopes.
Yeah, so Snellius and Stevenus. So they're not visible. They won't be visible on the 14th. They'll be visible on the 15th, right there. They're
Like in between the 2 days. This is where we run into that issue again, right? Where like if we had been in, let's say, the UK observing, then we would have been able to see the Terminator right here.
yeah.
But
So
we're only seeing
they're-
it here and here.
So they fall into sunlight fairly quickly, and you'll have to sort of, that's where the moon filter would come in handy. The neat thing about these 2 craters is, so the way the craters are named is there's the main crater that has the name after the famous scientist or philosopher, but then all the craters around them are sort of like A, B, C, D, E, F, G, and so on. And so I think the B's, so Snellius like B and like Stevenus B, are ray craters. So they're not on the list, but if you see a full moon, you'll see these 2 bright rays, like these bright spots emanating from that part of the moon. So those are the satellite craters of these 2 craters, making those 2 big bright spots on the full moon, which is sort of just a cool trivia. I call them the headlights. So it's because it looks like there's a car with its headlights just shining at you from that part of the moon if you're looking at a full moon.
What a full moon. Oh, that's cool.
Yeah, so that's those 2 craters there. Hopefully I've come up with enough interesting facts to at least entertain,
That's great. No, it's awesome. And that's all the targets that we have, which is fantastic. And a reminder, as John, you pointed out, some of these craters are really bright, like Tycho and even Copernicus, and some of the craters can be seen on a full moon. So just because we're saying go and observe on the 14th, 15th, or 16th, somewhere around there, doesn't mean that you have to. You can see them at other times. So Jamie asked, is there a list of this week's targets somewhere on the website? So this time around, we're not doing lists of targets because the list is basically just the program list. So if you go and look and I'll show you this on the website too. If you look at this spreadsheet, it has the Q day, it's listed by Q day. So it's basically just this list here. And today's Q day -5. So anything that says Q day -5 is on the list for today.
And you can look at the map, and as Jenna said, she has a calendar that you can add, which labels the Q day. So it's just basically you go to the calendar, figure out what Q day it is, and then you pop over to the website and look at the maps or the form. And I'm going to tell you, I used all the maps in the book and the program tools as well as the list, and that was one screen open when I was making all these moon maps. So they are the program tools and booklet is really essential for all the list and everything.
But I mean, the best thing to do when you first start is go out when you see the moon and just start observing and draw what you see. And I feel like after you've done that, everything just sort of makes sense.
Yeah.
After you've done that first night, even if you don't tick off any targets per se, you probably will.
Draw everything just in case.
Yeah, I mean, so I would, just get your telescope, point it at the moon, see what you can see, and then it'll just sort of make sense, and you'll know what which maps you'll need, and then you'll start looking at matching what you see to the map, and then writing and then just writing it down.
Yeah.
And
Having
and
this is a
sketching what you
helpful
see.
guide. Having your own moon map is a helpful guide. Having the observer's handbook or one of those program guides, they're all helpful. As we go along, I will start adding the descriptions of each of the observing days to this. So there may be more information coming in the calendar, so keep an eye on that. And eventually we will also, another thing that comes up is a lot of people are used to lunar days, not Q days. And so eventually we will also be adding lunar days to this. So for example, people in John's book is like this too. Lunar day 14, is the full moon, because that's lunar day 0 is the new moon. Lunar day 1 would be Q day -6 or so. And so if you use lunar days, or if you use an app that gives you lunar days, you'll be able to translate that into Q days once we add that column to that.
It'll be up by tomorrow, by the end of this week, the end of the work week. It's my job to do it. So I guess we're coming to an end. Homework for this week, at least what I'm planning on doing, is if it's not cloudy, I'm just gonna go out and try to do my sketch. I don't know how to do any sketching. As a little bit preview for next week, we're gonna talk more about sketches. Oh, Jenna, look how gorgeous that is.
How is that? It's not mine.
It's
It was
not
stolen by someone, from someone. They gave it to me. It's fine. Yeah.
So so hopefully all of you try to get out. I'll come back with what I've seen. As I said, I'm a very novice astronomer. This picture behind me was the first taken a couple of weeks ago, and it was the first time I ever went out with a telescope by myself, lined it up to the moon. So yeah, let's see what everybody has. Is there any last notes from John and Jenna?
I'll just say, do your best to head out on Wednesday, April 14th. That date is listed on the website as our observing day. That's the next Q day -5, where you'll be able to see the targets that we talked about today. So try to head out April 14th or 15th, 2021, in case you're watching this video in the future. Yes, so Paul says, and I think I get this, I'm interpreting this right, as the Terminator moves across the lunar surface, wouldn't there be 2 Q days? That is exactly right. So there are 2 options every lunar cycle to see things, and sometimes we'll be using the second option, and that is on the waxing phase. So today's, or the targets that we're talking about on Q day -5 is going to be in waxing, in its waxing phase when we get to April 14th, 15th. So it's going from a new moon to a full moon, so it's waxing. But if you wanted to go back later and go back, let's say after the full moon on Q day -5, which would be April 28th, you could do that too, and just download the waning -5 day, and that gives you this view from the opposite side. We're doing our best to aim for in the waxing phase, because that's when most people are awake. But of course, we're speaking to a giant group of astronomers who stays up forever. So who knows?
I really wanted to get out, but I couldn't bring myself to stay up.
It's hard, and it does take, it's really helpful to have other people to encourage you to get outside too. So best of luck with your observing this week. And let us know how we'll have a poll set up for next time to see how many of you got out and actually observed. And we'll see you all in a week.